Hello everyone, welcome to yet another video of measurement and instrumentation series. So in this video series we are already discussing about the light emitting diodes. So in the previous two sessions we have discussed about the introduction and history of LEDs, and in the last class we have discussed about the construction of LED along its working. Now we will see the types of LEDs. So as far as the light of the LED is concerned, it is determined by the fall of electron and hence energy level of the photons. Now we will see the types of LEDs. LEDs are produced in a variety of shapes and sizes, and the color of the plastic lens is often the same as the color of the light which is being emitted by the LED. The basic types of LEDs are modern high power LEDs such as those used for lighting and backlighting are generally found in surface mounted type. Some of the main types of LEDs are traditional inorganic LEDs, multicolor LEDs, bicolor LEDs, tricolor LEDs, organic LEDs, miniature LED, and high power LEDs. So the LEDs are available in different sizes, which is of 8 mm, 5 mm and 3 mm. Now let's see one by one. First let's see about the traditional inorganic LEDs. This type of LEDs are manufactured from inorganic materials. Some of the most widely used are compound semiconductors such as aluminum, gallium arsenide, gallium arsenide phosphide, and many more. So it is not a single semiconductor, it is a compound semiconductor, a mixture of 2 or 3 compounds so as to give or so as to achieve the required light that is to be emitted by the diode. Next we'll see multicolor LEDs. Multicolor LEDs, we have bicolor, which is 2 color emitting LEDs, and tricolor, 3 color emitting LEDs. In bicolor LEDs, 2 different LED emitters are in one case, and that is why it is called as bicolor LEDs. The first type consists of 2 dies connected to the same 2 color types of LEDs. The current flow in one direction emits one color, and the current in the opposite direction will emit the other color. The picture shows is for reference, which indicates the bicolor LEDs. The next is the organic light emitting LED, which is the OLED. OLED mostly uses display technology computer monitors, and they are mostly used in computer monitors, televisions, mobile phone screens. This semiconductor in the OLED is organic, which means it contains carbon. The OLED uses one of 2 polymer or small module. The OLED structure consists of the top layer, which has cathode, and beneath the cathode we have the emissive layer, which has the organic molecules or polymers, and below it we have the conductive layer, and below that we have the anode. And all these cathode, anode, and the conductive and emissive layers are being etched upon the substrate. Miniature LEDs is a type of LEDs which are surface mounted LEDs. They are available in common sizes. They are much smaller than a traditional 5 mm lamp type LEDs. Their typical ratings are 1.9 to 2.1 volt for red, orange and yellow color, 3 to 3.4 volt for green and blue, 2.9 to 4.2 volt for violet, pink, purple and white. The high power LEDs are those that are achieved by applying high voltages, and they have better luminance per watts. The given is an example. The picture shown is an example of high power LED, which is the Cree XPG series LED, which is achieved by 105 lumens per watt in 2009, while Nokia released the 19 series with a typical efficacy of 140 lumens per watts in 2010. Let's have a short comparison with the LEDs and the other types of lights. The life of a LED is much higher than CFL and halogen lights, and that is why LEDs are most preferred nowadays. And the watts consumed by an LED is very less, which means that it is highly power saving equipment, and that is why it replaces the traditional lamps. But the cost is slightly high, but that can be compensated by the power saving concept. And the kilowatt hour used over 25,000 hours is just 175 kilowatt hour, but compared with CFL and halogen, it is very less. The CFL consumes nearly 325 kilowatt hours, and the halogen hours are triple times higher than the CFL. For 25,000 hours, we need just one LED bulb, but whereas we need 2.5 LED bulbs for the same hours. But halogens, it is nearly 10 times higher than the CFL. Since the power consumptions and the number of bulbs needed for a longer period is less, the cost will be less, and hence the LED cost less and gives more lifetime. Maybe the cost of each bulb may be high, but compared to the lifetime and the watts consumed, it is cost effective. And that is why these LEDs are a good replacement for CFL and halogen bulbs. With this, we come to the end of the LEDs. In the next video, we will see a short comparison of all these types in detail. Thank you.